Okay, the next system we'll talk about is CVT, or Columbia Vibration Technology. CVT, which stands for Columbia Vibration Technology. Okay. Now, this system is really unique in the world. It's unique from all concrete products machines. Something that Columbia Machine has come up with, and a time-proven technology. The way this works is that we have a mold. And this mold is directly connected to a vibrator shaft down below. And through the rotation of this vibrator shaft, translated through these vertical shaker shafts, the mold is moved vertically through its amplitude. Because of the direct connection to the mold, this mold amplitude is constant throughout the machine cycle, irrespective of the weight of the mold or of the condition of the mold being empty or full or under compaction. In the Columbia machine, we have a pallet table and a pallet. And this pallet, instead of supporting the mold, the pallet is actually presented to the mold at the bottom of the mold. And so I'll just draw some rough representations here of airbags. But this pallet is supported by a table and airbags which act as springs with adjustable air pressures. And what this allows us to do is to present the pallet to the mold under vibration. For the fill cycle, we can use a relatively low air pressure in the airbags, which gives it a low spring rate. And the pallet that's being impacted by the mold will actually come away from the mold slightly, giving air gaps, which evacuates air from the bottom of the mold, resulting in a quicker fill cycle and a more complete fill cycle down to the bottom of the mold. When we want to compact the product under compression, we can switch these airbags to a higher air pressure, giving them a higher spring rate, and this pallet being pushed away from the mold will actually recover to the mold quicker, giving it less air gap in the cycle and a nice, tight, clean, crisp bottom surface of the concrete product. So this is very important to allow quick filling of the mold. We present the pallet to the mold instead of supporting the mold, and having the dual air pressure to give us a good fill cycle and a higher air pressure for a good sharp edges on the bottom of the product in compression. Another feature of Columbia mold is that the mold overheight is relatively low as compared to the competition. if we compare the Columbia mold with the table vibration mold making block, for instance, on the Columbia mold, we'll have a mold cavity like this. There will be a core bar in the center for the cavity, and this core bar then is supported, or this core is supported by a core bar that runs over the top of the mold. And so this overheight is relatively short as compared to the height of the product. In a table vibration machine, for instance, the tops of the molds are generally flat. And so on these molds, core bars tend to be built down into the mold themselves. So filling this mold cavity, you fill it to a greater height, which means in order to come down to a finished height, this concrete has to be relatively loose to allow for that compaction. In the Columbia machine, we do our work in the fill cycle. And this mold overheight is relatively low, and so we will not only fill the mold, but we'll densely fill the mold cavity. And then when we go into compaction, we're only compacting or finishing the product a little bit. What this allows us is to more accurately fill every mold cavity densely with concrete, so that we have more consistent product across the mold and from cycle to cycle. In the Columbia machine, in the Columbia mold vibration, we bring our shoes down into the mold, into compression. And what's happening now is that the mold itself is a controlled vibration. It's a true vertical vibration, so that there is no horizontal movement of the mold. This is done through parallel bars, which are basically a non-wear item guiding the mold vertically. By controlling the mold vibration, the mold throughout the height of the product is vibrating and getting all the particles in movement. And when we go into compaction, into compression, we use a relatively light compaction force using airbags on the head, so that we don't really force the shoes into the concrete, but we allow the shoes to follow the concrete into the mold as the vibration consolidates the concrete uniformly. This is how the Columbia products off of a Columbia machine will have very uniform texture and density throughout the height of the product. We fill the mold cavities densely to a short overheight, and then in compression, we don't really squeeze the concrete, but we follow the concrete as it is consolidated under vibration to give a very uniform, accurate height of the product in the mold.